Okay, now this is the time constant calculation which connects to the 555 timer, which you're familiar with. Pin 4 and pin 8 go to the top rail, pin 1 goes to the bottom rail, pin 3 is the output, and we'll use a resistor and we'll use an LED. Pin 6 and 7 are the actual timing bit, and this is the bit I want to concentrate on. So that's a variable resistor, sometimes called a potentiometer. This is a capacitor. That's the connection. This is the bit we're actually concentrating on, but however the circuit is actually triggered by pin number 2 going to a switch and typically a 10k resistor. So that's a press switch, some sort of pull switch that goes on and off. This is typically 100k and this is typically 470 microfarads. So that's the basic circuit. Now, what we're looking for, when the switch is pressed, a voltage occurs across the capacitor and the capacitor charges up, and the LED comes on for the amount of time it takes the capacitor to charge up to 2/3 of the supply voltage. Now, it's a 9-volt supply, so the LED will be on for the time it takes that capacitor to charge up to 6 volts, which is 2/3. If we draw a graph where this is voltage and this is time, the actual capacitor charges up like this, which is called exponential growth. The 9 volts is there, it never gets to the full 9 volts, so that's why we have to charge it to 6 volts. So 2/3 is 6 volts, that goes across there, that goes down there, and that T is the time constant, which is equal to the capacitance times the resistance. So that's what we're going to move on to next, how to do that calculation. We've got a value of 100k and we've got a value of 470. So we start with the formula. Again, this is on the formula sheet, so you don't have to remember it, but you should know it by now. The time is in seconds, the capacitance is in farads, the resistance is in ohms. So T is equal to, now taking the values from the other one, 470 microfarads times by 100k ohms. That bit's called substitution, so we put that in there. So if you can put the values from the question into the formula, you'll get a mark for that. You'll also get a mark for actually writing the correct formula down. We'll now have to do the math side of things. So where we've got 470 microfarads, the microfarads, we have to write it as 10 to the minus 6. We've got a time sign there, and the k, we have to write it as 10 to the 3. We've still got the 470 to deal with, and we've still got the 100 there to deal with. And everything's a time sign, and that's important for later. So the next stage, remember to keep your working out in line, keep the equal signs in line. It makes it far easier for the examiner to actually mark the work, and you've got a much better chance of them actually being able to understand your thinking if it's all nicely laid out. Even if there's slight errors there, they'll be able to pick those up. Now, because there's powers, we have to deal with the powers, and the rule of indices says if you are timesing, which we always will be, then you add those powers together. So we've got minus 6 and plus 3. So we deal with that first of all, and minus 6 and plus 3 leaves us with minus 3. So that cancels out and that cancels out and leaves us with that. We've still got the 470 and we've still got the 100 to deal with. We're now with that. Now T is equal to 470 times 100 is that plus 2 noughts on, which is the 100, times by 10 to the minus 3. Now that 1000 there could be written as 470 times 10 to the 3, because 1000 is the same as 10 to the 3. 10 times 10 times 10. Times by this 10 to the 3, which we've still got to deal with, Now we've got a +3 and a -3 powers. They will cancel out because we add 3 and -3 and that cancels out. So we've now got 47. So the answer T is 47 seconds. Now remember, going back to the question, that means, if this is the symbol for the chip, that means the LED or the buzzer, whatever's on, there's the LED, there's the resistor. Don't get thrown by the fact that the LED is in front of the resistor this time. It can be either way round, it still controls the current, and the rules still apply about voltage. That means that that LED is on for the amount of time it takes for this capacitor, which is pin 6 and 7 together, to charge up to 2/3. If it's a 9-volt supply, 0 volts, it would take 47 seconds for that capacitor to charge up to 6 volts. That means that this would be on for 47 seconds. Often the calculation and the reality are different because the capacitors aren't very well made, the resistors aren't very well made, they're not very accurate, therefore the actual calculation could be quite different to the real thing.